The Arctic fox. The Arctic fox gets its name from where it lives, in the Arctic. The Arctic is located at the most northern part of the world, around the North Pole. Arctic foxes live on the land and sea ice where they hunt birds and other small animals. But they don't always look the same from season to season. When the days get shorter and colder, their coats get thicker and whiter. This is what an Arctic fox looks like in the spring. And this is what it looks like in the winter with its winter coat. The most important thing about the fox's winter coat is that it keeps the animal warm. With its extra thick fur coat and bushy tail to wrap around its body, the Arctic fox is better at holding onto its body heat than nearly any other Arctic animal. But their fur does more than just give them warmth. Their white coat also camouflages them, or helps them blend in with their surroundings. Blending in with the snow lets the foxes sneak up on their prey, like Arctic hares and small birds, and it also helps them hide from bigger animals that might want to sneak up on them. But when the seasons change, so do their coats. In the summer, Arctic foxes shed their white coats and grow new ones that are brown or gray to blend in with their surroundings after the snow is gone.
Ah, the Arctic fox. The Arctic fox has the best insulating fur of all the mammals. When you insulate something, you protect it from losing heat. So the fur on the Arctic fox keeps the body warm because it protects it from losing heat. 3 animals, 2 that go along with the Arctic fox, so the Arctic fox, the snowshoe hare, and the weasel, also known as the ermine, these 3 animals have pretty cool fur. Their fur changes in the cold wintry months, or it changes to prepare for the cold wintry months. It changes color because it needs camouflage to protect itself from predators. And it also becomes thicker or warmer to insulate the animals for the cold wintry months. There is another way that animals stay insulated against the cold. Marine animals, animals that live in the water, have something called blubber. And blubber is a thick layer of fat underneath their skin. The right whale, who lives in the Arctic and the Antarctic parts of the world, has blubber that is a foot thick. So can you imagine underneath your skin having a layer of fat this wide around your whole body? That is what the right whale has. Animals and objects lose heat 3 different ways. First, through conduction, which is when items touch each other. Second is through convection, which is when warmer parts move up and colder parts move down. And third is through something called radiation, electromagnetic waves. Think about how your microwave works. When I go into my freezer and take the ice out, the ice is going to melt. But why? Ice melts because the air in the room is warmer than the melting point of ice. Heat from the air is transferred to the ice, causing it to gain energy and causing the ice to change to liquid water. If you want to keep ice from melting, you need to insulate it. You need to keep warm gases, the warm air, or warm solids, the tabletop or the counter or the glass, or warm liquids from touching it. We also need to keep it away from radiation, so we're not going to microwave it. This brings us to the STEM challenge. Can you design a container that has the best insulation in it to keep your ice cube from melting? You're going to need to find some great insulating items for your ice cube. as a reminder, and in case you don't know, metal is not a great insulator. Metal is actually a great conductor of heat. So think about if I take this metal spoon and I set it on that stove back there while it's heated up, that heat is going to transfer into the metal. So when you're looking for good insulators, think about what would keep you warm if you were cold. Do not choose metal. Let's take a look at your directions. For the Don't Melt the Ice STEM challenge, you are to design a container that will keep ice frozen for the longest amount of time. For your materials, you could use styrofoam from packaging, bubble wrap, fabric, packing peanuts, craft foam, pom-pom balls or cotton balls, straw, hay, small towels, wood shavings, whatever you can find that you think would help you in the Insulating STEM Challenge. For part of your materials this week, you are going to need 2 containers. You're going to want those containers to be as similar as possible, and you're also going to want lids for them. If you would like to do more than one challenge, look at a couple different things for insulation, you could do more than 2 containers, but 2 for sure, because 1, you're gonna have your STEM challenge in it, so you're gonna have your insulation with the ice cube in 1 container, and the other container is going to be something called your control. This container is only gonna have ice in it, because then you'll be able to compare your insulating container and your control to see if you are truly keeping this one warm. Let's take a look at what materials I used. For my materials, I am going to use 2 glass containers with 1 ice cube for each. I've got some cotton balls, I have some pieces of fabric that I'm going to use, and then I also have created a recording sheet because you are going to have to record some data for this STEM challenge. So for this, you are going to have to take your control after you put the ice in and put the lid on, and then you're gonna create your warm insulating spot for this other container, and then you're gonna put the timer on for 10 minutes. I want you to set up your recording sheet to look a little bit like this. 10 minutes, 20 minutes, you're gonna do 10-minute increments to check on your ice cubes. You can decide when your final time is. Mine I wrote down is 1 hour and 20 minutes. You could have it be an hour, 60 minutes. You could have it be after 30 minutes. You get to decide what you're going to have for your time intervals. So I've got my control ready, and now I've got to build my insulating ice cube container. So it's been 10 minutes, so I've taken the lids off and we will check our experiment. The ice that's the control has a little bit of a puddle in there. So I am gonna write down on my recording sheet, I'm gonna write small puddle. And then I'm gonna take a look at my insulation. And I'm gonna try not to touch my ice. And that is how it looks. The fabric's not wet and it still looks pretty intact. So I'm gonna write underneath mine that it still looks pretty good. And then I'm gonna keep going the whole rest of the way every 10 minutes. Good luck on your insulation experiment.